Hello, students. I hope everybody's well out there. I'm doing great. It's good to be back together again. Today, we are going to be getting into our next unit here about natural resources. I will say this is a whole chapter covered in just 1 week. Sorry about that. I do that because it's difficult to find labs to do together, and I like to have some labs to do, to keep it interesting for you. And there has been much more interest in green technology lately. So therefore, we might have more labs in the future. But right now, I only have the lab we have today, and so we're going to cover this in 1 week. Sorry about that. Have fun reading. Okay, so what are natural resources? Okay, so we're going to look at various things that give us a resource is something you used for something. Okay, so you use it for something. For instance, a tree would be a natural resource for building your house, right? Because we use the wood to build your house. Okay, so we have forms then that will give us energy as well. We want to get energy out of things. For instance, right now, you might have the air conditioner on your house. You probably have the lights on. You certainly have a computer on. Well, you need energy to run those systems. And so in order to find the energy for that, we've got to figure out a way to generate the energy. And so in order to do that, we need some resources. And we're going to be looking at renewable energy resources and non-renewable energy resources. In other words, things that get used up, and when they're all gone, they're gone. So let's start over here with our renewable energy. The sun is always there, right? So it is always beaming down its wonderful sun rays. You know how powerful they can be. If you go out in the summertime, you might end up with a sunburn because it's that powerful. Well, that energy, what it does is it allows plants to make their own food, and then that food is food for us. And furthermore, it is creating plants for various other uses more than just food. So that is renewable because the sun is always there. The plants will always come up and grow according to photosynthesis. We have hydropower, that's water. We have water renewal and water movement. So we use water frequently, like through a dam that will splash water through it, turning something. Essentially, here I'm going to have energy. If I have something that's moving, then that's going to be energy. Okay? Because we have rain, that is renewable, it happens naturally, then that is something we can use over and over. We have wind, right? So wind energy. Wind is moving things, right? It's blowing leaves and things around, and so therefore you know that there's motion there. If there's motion, I can try to capture that motion and use it for energy. Geothermal, right here, it's showing a volcano down here. It turns out, deep in the earth, things get very hot, right, as they get now closer to the core of the earth. And so there have been some inventions of sources to try to tap into that natural heat down there. For instance, if I put pipes all the way down to that heat, I can heat up some water. If I heat up some water enough, I can cause it to boil. If I boil it, I have steam. Steam is moving. The moving steam will create energy. All right. So we have these renewable sources right here. We're going to look at the advantages and disadvantages of each of those. Right now, our world is dependent upon non-renewable energy sources. For instance, something we call fossil fuel. Fossil fuel is things like oil, and from oil we make gasoline for your car. Okay, the gasoline burns in your car, and when it burns, it expands, which causes motion. It makes a piston go up in your engine. The engine then will go. It will move and move the wheels. We'll talk in a minute about why it's called fossil fuel. We have something called coal, also considered a fossil fuel, which is similar to oil, but instead of a liquid, it is a solid. So it's like a chunk of rock, and it's got a lot of energy packed in it. So if you burn it, it will burn well. So I can burn the coal, which will boil some water, which will create steam, which will make motion, which will cause something to move. For instance, a steam-powered locomotive right there, a train. We have nuclear energy, which is based on a type of element that is found naturally in the Earth's surface, in the core area, not the core, the surface of the Earth, the crust. Things like uranium, plutonium, things like this that are naturally unstable. And because they're unstable, they fall apart all on their own. And when they fall apart on their own, they send out little tiny itty bitty bullet type projections, and those can heat things up. And when they heat things up, once again, they can boil water, making steam. We can make it move. Natural gas is found almost always with oil and things naturally in the earth. It is a byproduct of a breakdown of some sort of organic material. And we'll get to each one of those. All of those can make energy. Notice energy showing you fire right there. Fuel for life. It's producing heat and light, boiling water type of thing. Soil can be a renewable resource if we take care of it. Remember we talked about, did we not? Did we talk about the Dust Bowl in our erosion? We did, didn't we? And how the the topsoil blew away. Well, here is a way to conserve it so that it won't blow away as easily. Notice instead of having straight lines, we have curved lines for our fields right here. And what those do is that will create some erosion control. Furthermore, we have some that are planted and some that are not. Okay, those are left fallow, and it means that they have been, plowed up, and there's nothing growing in them right now. They're going to have time to recuperate their nutritious elements in there, and then they'll plant them again. So we're learning how to take better care of our soil. Also, notice they didn't knock all the trees down. They left some trees up here. Guess what trees will do? Those will create a break, which will keep things from completely washing away or blowing away in the event of a storm or something like that. So soil is a renewable resource because we can grow plants in it. Plants will give us energy, right? We eat them and they give us energy. We could also, if we're growing a forest, burn the wood and create a fire. Okay, so we have a fuel source there as well. Now, when we are, you're going to read in your book about getting rid of our trash that we make. Okay, so right now there's a big push toward eliminating as much trash as we are making. We're trying to not be quite so wasteful, right, in our uses of throwaway things. So we do make a lot of trash, however, sadly. Landfills are areas that we use to get rid of our trash. Okay, so we actually dig a big hole, we dump our trash in it, we cover it up. We're trying to learn new ways of recycling things so we don't make so much trash, because the trash, notice all the plastic and stuff that's in there, that will break down over time and put in these non-organic materials that'll sink down to our water sources and cause all sorts of problems. So we're trying to learn how to be better stewards of what God has given us, how to take care of it better. You have, let me see the next picture. Yes, so here is a city landfill right here, and you can see how the idea here, it's called a dump, right? And they're dumping stuff in here. And the idea is we want to have smaller dumps. Here's a giant hole that they've dug in here. And we can see how we can be efficient with packing this properly by getting out some of the stuff that can actually be recycled. And so you may have a recycle bin at your house where you can put the glass in one bin and the plastic in another and paper in another. And that will help to keep from filling up landfills too much. Now you may not even wonder, every week you get trash picked up probably, and you never really wonder probably, where does it go? Well, it has to go somewhere, right? And that's just all of our trash going somewhere. You have a neat little activity in your book, in your student activity book, and it's called Packing the Landfill. It's on page 151. And if you want to try that at home, you essentially are just going to take a cup with various things to see how well they'll pack in. You get it wet to see if you can pack it a little further in and things like that. So give that one a try. I will say that personally I've tried to stop using as much plastic, tried to use more paper, things that can be more easily recycled. In science, oftentimes I have to use some plastic things. For instance, balloons, they're really important for me in science, and straws. And people have talked about getting rid of those things, but they do have their place. It's just, I think, being responsible with them is something God would like us to do. The ultimate renewable resource is water, and that's because water is always recycling, and it's doing it all by itself. Over here on the left, you can see that if we start with water in a lake, it'll naturally, on a warm day, some of it will evaporate. You'll feel that in the air. You'll feel a humid day when there's a lot of water in the air. It'll evaporate, it'll go up into the sky, and then it will condense. We call that condensation, and it turns into a cloud. And then when the cloud gets really heavy with a lot of evaporated water in it, then we get what's known as precipitation, and it will rain. All right, rain or snow or hail or sleet, any of those would be considered precipitation. It lands on the ground, it sinks back down into the groundwater, and it gets recycled. This word right here, transpiration, is when water leaves the leaves of plants. So you may have noticed standing under a tree, it's cooler than standing under an artificial structure like a garage or something. It's because there's a mist of water coming out of the plants on you. It's very, very fine. You don't really notice it, except that's why shade of trees is so nice. But you're going to see over here on the right, this graph right here is showing you that the vast majority of the water that we have on the earth, 95.25%, is salt water. Yikes. Can we drink salt water? No, don't drink salt water. So that means that the rest of the water out there, less than 5%, is what is known as fresh water and known as potable. I mean, you can drink it. So where is that found? Well, 2% of it is found frozen. Yikes again, right? So that's we have to melt that if we want to use that. And then we have groundwater, lakes, soil moisture. We have some in the atmosphere right here, which sometimes ends up as rain. We have rivers, and so we're going to see that it's important for us to take care of the water that's fresh. All right. It is possible. You may be wondering, is it possible to turn salt water into fresh water? Well, the answer is yes, you can do it. For instance, you could try this at home. If you had some salt water and then you put it into a dish, you could let the water evaporate, and the water would leave the dish and it would leave behind the salt. Therefore, the water that left was not salt water anymore, it was fresh water. But where is it? Well, it evaporated. So how am I going to get that? So in order to do that on a large scale, if I took ocean water, for instance, I could boil it, and then the steam, I would have to catch the steam in something and then recondense it and then turn it back into a liquid by cooling it. All of that takes so much energy that it's not worth it to do it. All right, so turning salt water into fresh water is very expensive right now. If you came up with an invention that inexpensively were able to turn salt water into fresh water, you would be a millionaire. Lots of people are working on it. It can be done, but like you can't just put it through a filter. Like if you put salt water through a filter, it would still be salty because the salt is really small and it stays in there. You have to get it out through a more advanced way. There is something that's been being worked on right here. This is some sort of computer chip that's being developed, my understanding is, at the University of Texas, Hook'em Horns, and it's some sort of component for a machine that can, they're working on this to see if they can desalinate some water. I don't know that they're successful yet, but you can see how computers might be useful for doing something like this. Maybe some sort of electricity that's going through it. Maybe it's some inexpensive way of boiling it. I'm not exactly sure. You may want to look into that, and someday you could be a millionaire, right, for figuring that out. Now, the groundwater that we want to get a hold of, so I don't know if any of you have a well at your place. Most people have water, brought to them by a water company. For instance, at my house, I use Aqua Water. They send water, right through my pipes, and I pay them every month for the amount of water that I use. Well, they have to get the water from somewhere, and it turns out they're getting the water from something known as an aquifer. So we've seen how, the levels of soil go down, right? And when you get to a certain lower level of the soil, you get to where there's only rocks. Do you remember that? And down there in the rocks, actually, water can collect in between those gaps in the rocks. And if you put down a well and you hit those areas of water, you can bring that water up to you and use it. You probably have to use a pump to bring it up to your house so you can use it. There are such thing as flowing wells. That means they're low enough right here that the water comes out. A spring would be similar to that. If you've ever been to Barton Springs or something, it's fresh water coming up from beneath and it makes a pool. And so that's a normal thing. There are also ones that are like that are natural, that are hot. So hot springs, I know in Arkansas they have a hot spring and you can go, it's like a natural hot tub out there. So it's important for us to keep our water table down here, our aquifer, nice and clean. Remember I talked about that landfill. If that trash starts to break down and some of that broken down plasticky stuff ends up down in our water, well, it's going to end up making our water not as good. It's not going to be as good for us either. So it's important for us to keep our aquifers nice and clean. Furthermore, if we deplete them, if we use too much of the water, it takes time for them to be refilled. And so I know in the area here, I don't know if you know anyone who works in our water company, the Aqua Water Company. I know that they're having a lot of competition. The city of San Antonio is trying to come tap into our aquifer over here and use some of that. Well, San Antonio is a really big city, so that they've been fighting against them like on that. Water is also available. We have the river running through our town, right? So we have the Colorado River, and that can also be used for a water source. We use an aquifer, however. Ice, remember 70% of the Earth's fresh water, which is already a small amount, is frozen. It's in glaciers and ice packs and things like this. Here we're looking at the Earth. This is North America. All right, so that's Maine. Right here's Canada. Look, it's very cold, obviously. Here's the Great Lakes. And up here, the North Pole, it's all frozen right there. Sometimes, remember when we have a glacier, if a part of it breaks off, it will form an iceberg or something like that. An iceberg is typically made of fresh water. So if you happen to be, come across an iceberg, that's some nice fresh water for you floating in a saltwater ocean. So our renewable energy, this is on page 155. We're going to be looking at the advantages and disadvantages now. So we are looking at, you have on your, in your little student book on page 155, you have a couple of little charts to fill in. We have water energy, wind energy, the next page is solar energy, and then fossil fuels. So we're going to go through these, and in each one of these little boxes, you're supposed to write down a few things of information about this resource. Okay, it's just 3 boxes, and we'll see what you can end up writing down about it. So when we're going to use water as a source of energy, remember water is renewable, hooray, that's good stuff. We can do that by putting in place this structure here, which is called a dam. All right, so you build a dam up in a river. We have it in the Colorado River, and you stop the water behind it. When you stop the water behind it, you create a reservoir, also known as a lake. All right, so like for instance, we have Lake Travis, we have Lake Austin. Those are all to the west of us. And the advantage of these is that the reservoir can be used as a recreational lake. So you can write that in one of your boxes. Recreational lakes. It's a lot of fun, right? Also, the water can be used to run through this dam right here. Look what happens. If it's going to run downhill, do you see how I've made a little bit of a waterfall? It's going through a little narrow hole right there, and the water's going to rush from being up here to down here. That's just plain old gravity. They open this gate, the water rushes through, and as it's moving, you hear that? It's moving. It can go past, this looks like a little bitty fan. It's called a turbine. It's a fan, so picture yourself blowing on, a pinwheel, right? So you blow on it and it moves it. Well, the water starts to move that. If I have motion, guess what? I can get energy there. That is turning around. It has little magnets that go to this generator that make electricity. So we have electromagnetism, and electricity goes up through these lines. Here it gets bolstered or boosted and then sends out electricity to our houses. So most of the energy we have in this area is indeed coming from the use of the river and the dam in Austin. So we call that hydroelectric power. Now, there's also a disadvantage, and that is when I make a reservoir, some of the land became flooded. So before they put the dam in there may have been people who had houses along the river, and they had river houses. Well, they came in and said, well, we're going to turn this into a lake, and some of those houses would have had to been, taken down, would have had to be removed. Probably the state who built the dam would have paid them for that, but it is a little bit of a disadvantage. We talked last week about the Nile River and how it brings all that wonderful soil down the river. They put a dam on it many years ago, back in the 1950s. They put the Aswan Dam in there, which created a massive lake called Lake Nasser. And when they did that, it literally flooded one of the most beautiful ancient Egyptian sites called Abu Simbel. And what they decided to do, since it was such a beautiful ancient thing built by the ancient Egyptians, big giant statues, They actually moved that whole thing up. So they took the statues at Abu Simbel and moved them up the mountain to preserve them because they knew the lake would be a problem right there. So that is one of the disadvantages. But we can get around it by planning well. Trees. Trees are a fantastic resource. This is not in your little charts right here, so you can wait to write anything about this. What are trees doing for us? Well, one, they're going through photosynthesis. They are making oxygen for us. Two, what about fruit trees? They're making fruit for us. That gives us energy. But these trees we're looking at are ones that are going to give us lumber. Lumber for building houses and things. All right, so we can see here what we can get from a tree. Down here at the bottom, lumber for building furniture and houses and things like this. Right over here, look at this. We can make paper. So this is talking about paper cartons, maybe like you would put your milk into or something, paper board. And so lots of that. Furthermore, paper we use to write on. Byproducts from paper making and woodworking, we can get bioenergy from that. That's from the bark and byproducts. So it's a very good way to not waste any part of the tree. So we become very efficient in our use of trees. Wind energy. This is our next one on page 155 right here. And in fact, we're going to do our little lab on this one today. You've probably driven through an area and seen these massive windmills up. And they're spinning, right? And because, what are they catching? They're catching the wind. The wind is moving those blades. And when it moves, guess what? We have energy that can be used. So what is the advantage? Well, once they're put up, because they're pretty expensive, and they're massively huge. You may have seen, I know down 71, I see them driving one of these blades before, and it's just like a gigantic blade. It's massive. But once they're up, the advantage is they have little maintenance. Now, the disadvantage, however, and we're going to see this in our lab, is that, first of all, you need to have wind all the time, right? And one windmill is not going to do you any good. You have to have a bunch of windmills. And so when those windmills are all going at the same time, they take up a little bit of space. Some people don't like the way they look. I think they look kind of cool, but they're not on my property. If you live near one, you'd be kind of surprised at how noisy they are. They do make a loud, swooshing sound. The wind, of course, is making its own noise. Furthermore, we have not really discovered a way to store the energy. So, for instance, if we have a really windy day, great. But if the next day is not very windy, we couldn't really store the energy from the previous day. And so we're having, on a non-windy day, what are we supposed to do? Have no lights, So it's a little bit iffy that way. There's another disadvantage you can write down in your box if you like, and that is that birds have been killed by those giant blades fairly frequently. Yeah, so that's a bummer. They don't notice them or see them soon enough or something, and they get smacked by them and killed, sadly. Solar energy. Now you turn over to page 156. You're going to have your little chart to fill out on solar energy. Now, great advantage is when they work, they're really great. They have no pollution created. There's really not a lot of bad side effects that way. However, they are expensive. Mostly the top of them are made of glass, and that glass, to let the sun come in, right, that glass can be damaged by hailstones and things like this. Really, to get enough energy, sort of like with the wind, you can't just have one little, array there. You have to have a bunch of them. You see massively, we have lots of arrays right here. Now, if this guy's living out in the desert, that's kind of nice because it's very, very sunny in the desert. In Texas, we have a lot of sun most of the year, but there are some places that it's more cloudy most of the year. And so really the bright sun is the best use for the solar energy. So we're still, and furthermore, we haven't figured out a really, really efficient way to store this energy either. So at nighttime, we don't have that energy coming in. But there are some, this is getting more and more successful lately as we're learning more about it to see if we can make these arrays smaller to capture this energy, because we certainly know that the sun is offering lots and lots of energy. It's always there, right? Especially for places that have a lot of sunshine for most of the year, like in Texas and in deserts and things like this. Let's watch a little video.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades. So what's stopping us from being completely reliant on solar power? There are political factors at play, not to mention businesses that lobby to maintain the status quo. But for now, let's focus on the physical and logistical challenges. And the most obvious of those is that solar energy is unevenly distributed across the planet. Some areas are sunnier than others. It's also inconsistent. Less solar energy is available on cloudy days or at night. So a total reliance would require efficient ways to get electricity from sunny spots to cloudy ones, and effective storage of energy. The efficiency of the cell itself is a challenge too. If sunlight is reflected instead of absorbed, or if dislodged electrons fall back into a hole before going through the circuit, that photon's energy is lost. The most efficient solar cell yet still only converts 46% of the available sunlight to electricity, and most commercial systems are currently 15 to 20% efficient. In spite of these limitations, it actually would be possible to power the entire world with today's solar technology. We'd need the funding to build the infrastructure and a good deal of space. Estimates range from tens to hundreds of thousands of square miles. Which seems like a lot, but the Sahara Desert alone is over 3 million square miles in area. Meanwhile, solar cells are getting better, cheaper, and are competing with electricity from the grid. And innovations like floating solar farms may change the landscape entirely. Thought experiments aside, there's the fact that over 1 billion people don't have access to a reliable electric grid, especially in developing countries, many of which are sunny. So in places like that, solar energy is already much cheaper and safer than available alternatives like kerosene. For, say, Finland or Seattle, though, effective solar energy may still be a little way off.
Okay, so you see how we have some hope for that to be developed as we keep learning more and more and how to make them smaller, maybe. And then once again, you have to be in a sunny place, right? Fossil fuels. All right, this is our last little structure you're going to fill in here on page 156 down at the bottom there. So what are fossil fuels? This is interesting, honestly, is that we're starting to rethink some of this, but fossil fuels are called that because we believe that they were formed, they're made of organic substances. Organic substances typically come from living things. So we think that oil and coal came from the buried remains of living things, animals and plants. And so coal particularly would be from plants, and then oil we think came from animals. And so, in other words, fossils, bones, the remains. And so you could even hear people say that it's from dinosaurs. Okay, so but the truth is we're not exactly sure that that's where it came from, but we do know it's organic. We do know it's found naturally in the earth. It is non-renewable because once we use it up, it's all used up. So they what are the advantages? Do I have that? Let's see. They include crude oil, which is right down over here, so the black oil right here. And notice how gas is on the top, right? Gas is going to be lighter, and almost always with oil we have gas at the top. In fact, that somehow is sometimes how we find it. Notice how this is really deep underneath this mountain right here. It's going to be hard to get to that one, but if I dig a hole, see, here's like the water, the ocean. If I dig a hole this way, then I can tap that gas, and if I can capture that gas, I can use it for your furnace or your stove or something like that. But then the oil down here is, of course, liquid, right? Where is it? Right here. The oil would be liquid. And I could get that and use that to refine it to turn into gasoline for your car. Down here we can see, there's some more right down here. Notice we have to dig through this rock to get to it. Otherwise, that gas would have escaped all by itself, right? Let's see if I have another thing on here. Okay, yeah, so this is going to show us some of the advantages and disadvantages. So first of all, petroleum, known as liquid rock. It's the oil that's down there, and it's kind of a thick, greasy black color. And we use it for lots and lots and lots of stuff. So you can say one of its advantages on your little chart is that it's very useful for making things. For instance, we make plastic, paint, fabrics, women's makeup. These all come from petroleum products. So almost all the plastic you can think of, you probably look around your house right now and see what kind of things are made of plastic. Plenty, right? I'm looking at my computer case right here, my keyboard, my new microphone. It's got a plastic part to it. That all comes from petroleum products. We also use it for energy, for heating our homes, producing electricity, everyday use for gasoline in our cars. Now, in order to use the crude oil means it's in its lowest form, we need to we need to refine it into products that can be more useful. Right here on the right, what you're looking at is an oil rig. So that's a oil pump that's pumping it up out of the ground. If you've been driving through East Texas, you can see it going up and down, right? And it's pumping oil up out of the ground. And we take that oil and we use it for many things that it can be used for. This is a oil rig that's out on the sea, out on the ocean. So it's an oil platform. And that's because it turns out we can find lots of oil underneath the ocean. If you go down to the Texas coast, you will see these off in the distance in the Gulf of Mexico. And we have people who live on there, and they send this oil rig. They send all the way down, drill all the way down to the bottom and pull that oil up, and they get it out and take it to refineries. We have a lot of oil in Texas, it turns out, and furthermore, we have almost a good portion of the refineries are over in the Houston area. If you've been through Houston and seen some of those big machinery and stuff, a lot of it is refining oil. Natural gas is very clean. It's non-renewable because we have to find it. Also, it's a little more difficult. Once we get it, we have to trap it, right? Because it's gas, it'll just spray off. In the old days, when they hit oil, they would burn off the old natural gas until they got the oil there. Then they realized, wait a minute, if I can burn it, that's heat. I can have energy right there. Okay, so it is an excellent source if we get it captured. It can be very inexpensive as well. There's different kinds of natural gas. There's the one that's just known as natural gas that you may see coming through your stove like this. At my house, I have a different type of natural gas called propane. And so propane also is found naturally. They can actually condense that down. If you squeeze it enough, you can actually turn it into a liquid. And so when they put it in those big tanks outside, it's a liquid. When they bring it as a liquid, put it in there. But when you bring it to your house and release it and put a spark to it, it makes a flame. So it turns into a gas. It's a very efficient way to heat. It's an excellent source. Coal is probably formed from plant material that's been buried, old peat moss and things like this. It is, because it's got organic material packed into it, it's got a lot of potential energy stored in it. So it turns out, it kind of seems weird if you're going to burn a rock, right? But you can put this in a fire and it'll smolder. It'll just have nice heat coming from it. It won't turn into a big old like forest fire, but it'll have a lot of really great heat. And it's an efficient and wonderful way to heat things. The people up north in our country, in America, use this almost primarily for their heat in the winter. So they burn a lot of coal. So we have to go dig it out of the ground. So one of the advantages is that there's a lot of it, and it is very efficient. One of the disadvantages is when it burns, it leaves a lot of smut everywhere, a lot of black residue, and so it's kind of messy. And furthermore, going down to get it, the guys have to go down into a deep hole, and it's kind of dangerous. They have to dig it out, so there's disadvantages as well. Furthermore, there's different kinds of coal. It turns out, of course, the best, most efficient coal naturally, it's going to be this one, right? The anthracite right here, then lignite, and then we have this bituminous. Bituminous is the one we use mostly for burning in the winter time and that kind of thing. We use these finer ones for other processes. It helps to burn it to make things like steel and things like that. Now, nuclear energy is an interesting prospect right here. I'm going to show you a picture of a nuclear reactor. Okay, so what in the world is going on with nuclear? When I was growing up, it was being touted as the new greatest way of getting energy. But a lot of people thought that it was also very dangerous. And the reason that they thought it was dangerous was because you use something called uranium, which is a naturally radioactive element. That means it's unstable in its natural form, and it's falling apart all by itself. And when it falls apart all by itself, it sends out these little particles called beta particles. And when the beta particles shoot out, it's like a little tiny bullet that shoots out. But if that little bullet shoots out and it shoots a bunch of them out, I can actually create heat from the friction of that, which can make energy, right? And so, but because they have a little leftover amount of that radiation, it will leave some of that radioactive materials in whatever it touches. For instance, I take my uranium, think of uranium as like a rock, and we take that and we refine it down to where we get the most important part of the uranium. It's the uranium that has the radioactive part of it. Not all uranium is radioactive, only a small percentage of it is. So we have to refine it down to where we get only the percentage that's radioactive. Okay, remember, it's falling apart by itself. It's sending out little beta particles. We put those in the form of a rod down into this little vessel. Okay, they're called control rods, and the vessel has water in it. So when they're shooting out those little beta particles, it's causing the water in here to boil. Then the water gets sent up into here, right? And look what's being made. Steam. That's how much it's heating that water. It can turn the water into steam. The steam gets pumped through here. It's going to turn this little fan turbine. When it turns the turbine, it'll turn the generator, which has the magnet, which creates the electricity, and we send the electricity out, and you get light. You get air conditioner. You get what you need right here. Now, all of this is taking place in this thing called the containment vessel or containment building. And so it's important that this containment building be built very, very well. Otherwise, if there's an accident usually is when water runs out of the vessel right here. For some reason, it shouldn't. It's happened before that the water runs out and we don't know it. There are people always watching it to make sure there's always enough water in there. Otherwise, it's not working, right? If there's no water, there's no steam. All right, and we got to keep those control rods cool. We got to keep the uranium fuel cool so that it doesn't just start to melt stuff. So let's say the water runs out. We have an accident and there's no water in here. It runs out. Well, what will happen is this will heat up so much that this whole little vessel right here will actually dig all the way down through the ground. That's known as the China syndrome. The idea of digging down to the ground, you end up at China, right? It's just kind of a silly little kids thing. So in America, we had an accident in a place called 3 Mile Island. This was in Pennsylvania back in the 1970s. And what happened was the computer said that there was water in the vessel, but there wasn't any water in the vessel. And so the thermometer started going up and up and up. And the people watching the thermometer said, why are the thermometers raising so high? Why is it so hot? Because this button over here tells me that I have plenty of water in there. Well, then they realized that that button was faulty, and they fixed it. They turned the whole thing off. They were able to replace that faulty thing in the reader there, and they were able to replace the water as well. So the water got so it was averted. There was no huge accident, but it scared people. They thought, oh, the whole thing's going to explode like a bomb. Well, it turns out the uranium in there is not equipped to explode like a bomb, so there can't be an explosion. But what can happen is that it can contaminate the soil under here, and the water, that the steam that comes out may have some contamination of radioactivity in it. And so that bothered people because it could get into the water, and the water, you don't want to be drinking radioactive water, it would make you sick, this kind of thing. So there are some genuine, problems with it, but we built our containment vessels so well, our containment building so well, that it wasn't going to dig down through there. Other countries, however, aren't as good as we are at building them. For instance, over in Russia, there was one called Chernobyl that it actually did burn down and cause a fire, and it caused a small explosion, not a nuclear explosion. And then over in Japan, there was one that had a problem. There was an earthquake and a tsunami. How are you going to, combat against that? And so they had to fix the accident on that one. When my son was taking English 5 is the class you take where you write a thesis paper where you try to prove whatever your point is. It's a very, heavy duty research that they do. And one of the guys in his class wanted to talk about how dangerous nuclear power was and that we shouldn't use nuclear power. And after he did a little research, he actually changed his thesis to say that nuclear power is actually the best form of power to have. It turns out when everything's operating well, it actually is one of the most efficient ways of creating energy. And furthermore, the country that has the most nuclear power plants in the world is the United States of America. So we are definitely using this source of power. There's our neutrons and protons inside the nucleus over here. When they break down on their own, then that's when the little beta particle gets shot out. Other resources. Minerals are non-renewable resources as well. These include metals like gold and silver. We use those for various things. You think about it maybe for jewelry and pretty things like that. But it turns out gold and silver are very important in our electronics, in our cell phones, in our computers. So some of those little wires in there, sometimes gold and silver are the preferable ones. Other metals, copper, iron, aluminum, very useful for household things. Right now, copper is very expensive because it's so good at conducting electricity. We like to use it to make the wires in our house between our lights and everything like that. So those are other resources. So we're going to look at good stewardship now. That is, how are we going to take care of this beautiful planet that God's given us? All of these renewable and non-renewable resources are a gift to us from God, and we need to use them properly, right? He wants us to use them. He wants us to discover all that He has for us, and so we just need to be good stewards of His planet. This is the picture that talks about recycling. You're going to be looking at some of those in your notebook as well, as far as how to tell what the little signs mean. And this is going to be our lab. Okay, so when we talk about being responsible, we're going to try to develop our solar uses and our wind uses. So that's what our lab is today. This, what I have for you, this would have been dependent on the day we were at class. We would have had to have a sunny day. And I had to actually wait for a sunny day. For the last few days, you may have noticed we've had rain and stuff like that. So this is my little mouse right here. And you see there's a little tiny solar panel in there. And it's clear so that the sun's gonna hit that. So I had a difficult time trying to get him to move. But once I got it going on the bright, bright sun, I'll show you what happened. Here we go.
Of a man and woman were found inside their
sunny day. For this to do this. Okay, here's my little mouse. I'm going to push him along. There he goes. Oops. Woohoo! All right, so there was my little mouse going, and it would have been fun. We would have had to take a table out with us. I don't think he would have done that on the sidewalk. All right, and now we're looking at our wind energy. Okay, so what I have here is a wind turbine that we would have put together, right? It has this little wooden thing in the pipe and this, and there's a little motor in there with the wires coming out the back right there. And then I cut out these little pieces that would go on this fan to make it go. So you can see I have wires attached here. These are called alligator clips right here that are attached. And then I have actually a little light bulb right here. I'm going to see if this is going to work for us. Okay. This is a box that will tell us if energy is coming out of the system. All right, it's a little, electricians use it all the time to follow which way electricity is going. Okay, so I'm going to play a little video for you. Hello students, here we are. This is a wind turbine. So I put this together as I showed you in our little picture there. Now I have some wind right here, a hair dryer, and I'm going to try to get this moving. And when I do, it should show us some power on this little box right here. So let's see if I'm going to have enough hands to do this. You can see, can you tell that it said 0 right there? Okay, I'm going to get the wind moving and then I'll try to keep the wind going and show you that at the same time. All right, here we go. Come on. All right, that's good. There we go. All right. Come on. There we go. It'll show it to you, then it'll stop. Okay, what that was doing was showing you that the meter started to register some numbers there to show you that there was indeed energy coming from the movement of this. Now, there's not that much energy coming from this, but it does show it on our little box. But I want to show you now, I have a little light bulb. And so the idea here is to try to light up this little light bulb, okay? So I've tried it many times and it never works. So let's see if it works this time. So I'm just going to connect these, get a good connection. Then I'll get our wind blowing. Can you see that little light going there? If it turns on, you should be able to tell. All right, I'll turn the light bulb around the other way, just in case I've got that wrong, which is indeed can be done. It's got to be the right circuitry. Let's try it one more time. If I can get that wind going, let's see. Okay. All right. So you see how I never got the light bulb to light up. And, I tried many different things. So the idea here is that, remember I mentioned to you that in order to get the wind energy to be very productive, we need lots and lots of windmills. So just the one windmill, although it's putting out electricity, we saw that on the little meter box, it wasn't putting out enough energy to light up my light bulb. All right, so it's not that it's a failure for our experiment, but it is that we would need lots more to make even just a light bulb light up. So the idea of using wind energy right now is still a little bit on that hopeful side, where we're not really ready to use it completely just now. Okay, in your book, you have an option to do a project, and I never do this with us in class time because it is very, very messy. It's called cleaning up an oil spill. And what you do is you actually put some water in a pan of some sort. I would use probably one that you could throw away or recycle, right? And then you put oil on the top. You know how the oil will float on the top of it? I'm talking about cooking oil. So this little up here they're using for cooking oil. You take up cotton and you try to soak up all the cooking oil so you can clean up the water. You see, this somebody here was using oil from your car, right? You could put that to float in there if you wanted to. So if you are desire to do that, check with your folks. Do it outside, I would recommend, because I don't do it in our classroom because it's way, way too messy, and it does take a little bit of time to do it. So I don't do that project. All right, on page 158, we have a few things to answer here. Let's see if we can get the answers for this. So number one, uses the energy of moving water to make electricity. What uses that? You remember that one? That's called hydroelectric energy. So that's B. A non-renewable energy resource from the chart. I mean, you're going to be looking at your box there. A, we're going to be looking at fossil fuels. They're non-renewable. Uses the flow of air to produce power. We know that one, don't we? Yeah, wind energy. Uses energy from the sun to provide power. We know that one. Solar energy. And forms when plants or animals are buried quickly and under great pressure. Those are called fossil fuels, right? So you were picking A, B, C, and D right there. Okay, good. Here we have choices here of reduce, reuse, or recycle. All right, so you're going to get to choose these on your own. So number 6, use a resource over and over. Which one do you think that means? What are you thinking? Could be reuse, could be recycle, right? Decrease the use of resources. Probably reducing. Process a new item from something old, right? That could be recycle. Turning off the lights in a room when no one is there helps conserve the use of energy. I would think reduce on that one. An empty soup can could hold crayons or pencils. There's reuse. I see how they could be recycled too, but I think recycle means you actually change it into something. Plastic bottles and containers are melted down and shaped into other things, such as garden furniture. That's definitely recycle, right? Okay, so that's you can talk with your folks about those and see what you think is the best choice for those. This is also in your book, and you should be able to, with using your textbook, go through each one of those and tell all of us what they are meaning. All right, I look at them and think, oh my goodness gracious. So some of them are for the plastic, some of them are for various things. So check those out in your book and see if you can. I think these are the same. This picture here is the same one like that's in your book. Okay, so that's it, gang, for this week. If we'd been together, we would have worked a little more on that wind right there and possibly made a pinwheel, that you would just blow, and that would turn it just for a fun little project right there. Okay, next week we'll be getting together and start to learn about our human body, so be thinking about your projects of your model. Okay, great, guys. Have a good week. Bye.